Hello everyone, my name is Zhimin Wang, and welcome to my presentation on software architecture final project. My project name is CollaborAI. CollaborAI is a unique platform that aims to bridge the gap between technologic and non-technologic individuals, making it easier for anyone to leverage the power of OpenAI's cutting-edge technology. With CollaborAI, users can learn from each other, share ideas, and collaborate on exciting new projects. In this presentation, we will take a closer look at CollaborAI's background, features, and architectures, and explore how it can help you achieve your goals. So let's dive in. For this project, I have two architecture options. The first architecture I've selected is the layer architecture. In this architecture, CollaborAI is divided into four layers: presentation layer, business layer, data access layer, and a data storage layer. Within the business layer, I have added a security service to obtain login user information and provide global context for calls to other components. Collaboration engines have been added to enable live chat functionality by binding the topic ID and user ID with the front end and message queue. The message service is responsible for sorting and storing the chat records, while the third-party API service is used to call OpenAI-related interfaces. The presentation layer and the business layer communicate with each other via the WebSocket. To ensure the security, I have designed a authentication processing filter as a connector between the login view and the security service. The filter uses Bscript encryption and the decryption technology of the Spring Security. In addition, I have designed the collaboration binder and the collaboration engine to bind the chat information to the topic and user ID. For data storage, I have added two more layers, the data access layer and the data storage layer. The data access layer provides access to the data, while the data storage layer is responsible for the storing data. And I also use the ORM as a connector, which is the object or relational mapping for the data mapping and transfer. Moving on the UIM diagram of the layer architecture, we can see that it consists of four layers. Just let me zoom out. Okay. So presentation layer is at the bottom and corresponds to the classes related to front-end page display. And the data storage layer is at the top and corresponds to the entity classes. Although the diagram may look complex at the first glance, we can still observe that all calls between the classes follow the top-down or the bottom-up data transfer pattern of the layered architecture. For instance, the personal information view class calls authenticate user class for the user authentication. And the authenticate user then calls the user repository class to query the user information by username. And the user repository maps the queried user information and the user entity class via the circuit and the ORM, and finally returns it into the personal information class. Overall, the UIM diagram demonstrates how the different layers in the architecture communicate with each other in a hierarchical manner, making the system more organized and easier to maintain. Now, let's look at the mapping diagram between the components, connectors, and the classes. So first, in the presentation layer, we have various front-end classes that correspond to the different components. These include the inner classes like the chat info class, and as well as some detail classes like the person detail class. Additionally, we have two connector classes that handle the data encryption and the message binding. Moving on the business layer, We have interface that their implementation clauses that make it easier to extend the business logic and in the future. The chat room component is designed with a synchronized service and my synchronized configurer clauses to support the synchronized calls to the third-party interface, which helps improve the service concurrency and prevents the thread blocking. And finally, in the data access and storage layer, each table corresponds to a repository interface for query statement passing. We also have one or more entity classes for each table, since some tables may require more than one storage. Overall, this mapping diagram helps us to better understand the relationship between the different components, connectors, and the classes in our architecture. All right, let's move on the second architecture option for the CollaborAI, the microservice architecture. Let's first take a look at the level 2 diagram for this architecture. The microservice architecture is designed to split up service to provide scalability across the system. In this architecture, I split the front end and back end of the CollaborAI into two services, and then split the backend services into different microservices based on the business. Additionally, to speed up the page loading, I can deploy the static resources to a CDN. As you can see from the diagram, the client accesses our applications through a web interface or the mobile phone. First, fetching the static resources of the page from the CDN, then the request is forwarded to the node services through the Nginx load balancing, and the node services requires the different microservice backends through the HTTP interface. Middleware such as the API gateways is used to achieve user authentication and the flow restriction. The components of the backend microservices are similar to those in the layered architecture, with the difference that the calls between each component are changed from the directly call to an RPC call. After receiving this request, the backend microservice will across different databases to obtain data according to the business logic. However, in addition to a business service, the microservice architecture also requires additional infrastructure service for the service discovery, service governance, and other functions. The next thing I will discuss is the diagram for the microservice architecture. Since each microservice is independent, I will show several services separately for clarity. First, let's take a look at the front-end service, which is similar to the layered architecture, but I implement in the JavaScript instead of the Java. The connector between the front end and the back end is the RESTful API, and the front end chat connector and the security check connector has been removed by replaced by the distribute gateway and a message queue, respectively. Moving on the user service, you will notice that additional controller component, which provides the RESTful API. The former service has been transferred into the RPC service, which RPC with the RPC annotations that allows it to call other service in the remote way. Although there are several other classes that remain, but they're pretty much the same at the layer in the layer architecture. Just add more controller to provide the RESTful API. So I will not go into the detail to save the time. And now let's take a look at the mapping between the components and class in the microservice architecture. It is similar to the layered architecture, but each backend service now has additional controller component, as I said before. The connectors are converted to the either HTTP or RPC interfaces. This helps to provide RESTful APIs and improve the communication between different services. Since the changes are pretty much the same, I will not go into details again to save the time. After discussing the two architecture, let's go through their advantages and disadvantages. As we can see, the layered architecture is very straightforward and easy to understand, and the communication between different layers is clear. Its modularity makes it flexible, allowing changes to be made with ease. However, one disadvantage is that if the layers are divided too strictly, it can be difficult to maintain and modify, and there will be more coupling between direct calls of each layer. For large projects, too many layers can also make it difficult to manage. Moving on the microservice architecture, one of the biggest advantages is its extensibility. Since each service is independent, we can replace or update them more easily. And the failure of the one service does not necessarily mean the failure of the entire system. However, microservice architecture also have its downsides. For instance, it can be highly complex and difficult to manage, especially when dealing with the governance issues. Communication between the components may also be affected by the network latency, which can lead to slower response times. So while the microservice architecture offers great flexibility and reasonableness, it also comes with additional challenges that need to be carefully considered. Before we decide on the final architecture for our project, it's important to compare the pros and cons of both layered and microservice architectures. When it comes to implementation, layered architecture is simpler since all the code is in the same project and the direct calls between the layers are more efficient. On the other hand, microservice architecture requires additional infrastructure service for the monitoring and ensure the proper operation of the services, make it more complex to implement. In terms of the maintainability, layered architecture is better for smaller projects, since replacing the component in one layer usually only affects the adjacent layers. However, for complicated business scenarios and strict layering, maintainability can be reduced. With deployment, layer architecture requires replacing the entire jar package with downtime for deployment. In contrast, microservice can be updated independently, and hot deployment of static resources can be achieved through, like we said before, the CDN, something like that. So when it comes to scalability, microservice architecture offers more flexibility and adaptability to change in demand. As service can be scaled independently and horizontally, in comparison, layered architecture can be more limited since the entire application is packaged together, making it more difficult to scale individual components. Furthermore, the microservice architecture allows the distributed development and the deployment, which can increase fault tolerance. And so, however, implementing microservice can add complexity to development and deployment, which must be managed carefully for successful scalability. When it comes to this, you may feel like microservice architecture seems like a better option than a layered architecture, considering its popularity and advantages. However, the selection of the architecture cannot be separated from the discussion of the project's own requirements and background. In the case of CollaborAI, which mainly provide third-party interface costs and a personal management, the business logic is not complex, and the concurrency of the usage scenario is also not high. Therefore, a single service layered architecture is sufficient enough to support the project. Additionally, since this is a course project with a limited deployment cycle, it may not be feasible to develop a complete microservice architecture within a given time frame. Not to mention the additional cost associated with the purchasing cloud service, something. Based on this factor, the layer architecture was chosen as the best fit for CollaborAI. After this introduction, you should also be more excited about what CollaborAI is really like. Next, I will give you a demonstration of the specific function of the CollaborAI. Great. So let's start by running the application. Once you've entered the IP and the port, you will be taken to the default page, which is the CollaborAI chat room. This is the most important page where you can call the OpenAI's API, just like talking with a robot. You can also find the discussion type where all the users can engage in discussions. However, before we can start using those APIs, we needed to log in first. Otherwise, if you type hello here, it will let you log in to use this function. So click here to log in. On the login page, you can enter the username and the password that you have created in advance. It's important to note that the CollaborAI doesn't allow users to register themselves so far, and the users can only be invited by admin user to use the website. So let's use the account to log in. After login, you can see all the types of the CollaborAI, including the chat room, the user management, personal information, and API settings. However, the user management and personal information tabs are only accessible for the admin user. Before we start chatting with the AI, let's go to the user management page first. Okay, here you can see the information of every user in our system, and the admin user can edit or create new users. I will now demonstrate how to create a new user. So this is the previous history test users. I can create a new one. Test, let's say 2. Test SMU. And email, let's say SMU software gmail.com. Phone number, that's the first today. The access key is the key for us to call the OpenAI's API. So everyone can provide their own access key. But if they don't have the access key, I will provide mine for them to have a free trial. So this just for this version, we can have a free trial. For the latest version, we may have any other charging modules. And for the roles, we give it a user. And the sponsor tab button means if you provide the access key and it's usable, I will set you as a sponsor. Save it. Fresh. As we can see, we have the test SMU here. And let's open another type to so this is the previous chat history for the visitor, and we chat use the new users which we created just now. So the username is the email SMU software gmail.com. And the default password is the first name plus the last name. And the user can change it later in the personal information tab. Esther SMU. Let's see. Okay. As we can see, the normal user can only see two tabs, the chat room and the personal information. When within the personal information, user can edit their own information like the first name, last name, and even the password. So after adding the password here, updating the password here, we can use the new password for the user to log in. So go back to admin account. So let's go to the API setting. So for the CollaborAI project, we now have two APIs. One is the ChatGPT API, and the second one is the image generation API. And each API, you need to pass some parameters to call the APIs. So for the ChatGPT API, we need to pass the model, the temperature, and the max tokens. Each fields will have their own description. So for example, for the max tokens, it means the max length of the response of the OpenAIs. And for the image generation, it has two parameters to call the API. So for the image size and the response format. Let's save it. And let's go to the most important part, which is the chat room. We have three types here. I have already introduced it. So for the ChatGPT, we can just type hello, and you will see that we call the ChatGPT API for you and see the response as a chat robot. And let's ask what is layered architecture. Sometimes it takes some time to call the APIs and to. Okay, so this, because we are not the pro user of the ChatGPT, so sometimes it's a little bit slow. Thanks. Okay, let's go to the image generation tab. We can have a white, cute cat. And it will return the URL as we set in the API setting. And we can use this URL to get the images that here see a cute cat. And in the discussion tab, this place provides the users talk in the real time. So let's tap hello everyone, and we use the another account, the chat room, use the discussion. You can see there is an unread message here, and we can see the whole online users in the here. Put here, and we respond as hello. See, the message is always in the real time. I think this is almost all the features of the CollaborAI. Due to the time constraint, I couldn't divide into all the details of the logic and processing. But as previously mentioned in the architecture design, CollaborAI's feature include the chat engine, user authentication, synchronized calls, and more. Okay, let's go back to the slides. So overall, CollaborAI is a project I have been working on for 2 weeks. And while there are still some shortcomings, I will continue to add more features, such as the user restriction, API usage statistics, ChatGPT usage templates, and the charging modules. So if you are interested in the CollaborAI, please join me. And thank you all for the attention. Thank you.